So, minus 112 is in the math news again. And yeah, I thought I'd share a couple of thoughts of my own about what, well, if not an intuition, but what closest to an intuition we can have about this weird sum down here. And it's mostly picks up on where Tony has given a proof a couple of years back on Numberphile. I'm going to link the video right here. And he does some really interesting manipulations with infinite sums to get to this result. It's really a mousetrap of a proof where every single step is sort of acceptable. Most of them are really acceptable. One is a bit weird. But all of a sudden this result pops out and we are left wondering where exactly our intuitions left us. I will not rehash the proof here, but I'd rather think about, talk about what underlying assumptions are in this proof and where exactly they work, don't work. Well, that's your own opinion, but yeah, let's see. Of course, the first level of understanding this infinite sum of integers is to simply say that it doesn't exist, right? That is the very first reflex that one has when encountering a sum of an infinite number of numbers. So finite sums are perfectly fine. 1 plus 2 is 3, 1 plus 2 plus 3 is 6. We could even imagine summing up the first 100 integers. But an expression like this, first of all, doesn't exist. Yeah, we can write this on paper. Actually, we can't. At some point, we have to put an ellipsis. But the very first starting point is to say that this is an expression that doesn't exist. It doesn't have any mathematical sense. Things like an expression like the King of France doesn't exist anymore. In the very same way that these expressions don't exist. 1 divided by 0, 0 to the power of 0, the square root of negative 1, at first don't exist. I mean, you could argue that, yeah, with complex numbers we can have the square root of negative 1, but these other operations, division, exponentiation, are not defined for any number that you put into them. Yeah, they are exceptional cases where there is no meaningful way of assigning result to this expression. So these are sort of false expressions or pseudo expressions that just don't refer to anything in the mathematical reality. And truth be told, this also applies to these kinds of infinite sums at first. Yeah. So the sum of decreasing powers of 2, if it's an infinite sum, if you had asked the ancient Greek, they would have told you doesn't exist, doesn't make any sense. Yeah. Then of course you can build an intuition and make it mathematically sound to assign to this a finite result. Yeah. And there's a certain geometric intuition behind this, but definitely not when you add all the integers, all the positive integers. Well, the next level would be to say, well, we can add all the positive integers together, just result is infinity. It's a special value, a special kind of new number that we can add to the numbers that we know. And then there's a whole debate about it, whether infinity is a number or not, or could be treated as a number. I say it can perfectly well be treated as a number as long as it's a special number. But I mean, 0 is a special number as well. Yeah. And the mathematical properties of these special values are a bit different than of regular finite numbers. So for example, infinity will be larger than any finite number x. Yeah. Or if we add a finite number to infinity, we still get infinity. Or if we multiply infinity by any real number, we get plus or minus infinity. That is, we need to add a second special value, minus infinity, to make the arithmetic work. But then we are left with expressions like infinity times 0 that still cannot really be computed. Yeah, there's no meaningful way of assigning it any value. Or at least if you try, you run into contradictions. So that's this next level of understanding this sum. And I think we have a lot of intuition about this. It corresponds to our intuition of infinity. But really enough, there are these arguments that say, add all the integers together, the positive integers, and you get minus 1/12. And that's really weird, because we sort of can accept a special value for this infinite sum, but not really a value that we already know of. It's sort of very similar to when you were first exposed to fractions. So for example, in grade school, or primary school, you are taught that, for example, 5 divided by 3 cannot be computed, does not exist. Or you could say 5 divided by 3 is 1 with the remainder of 2. But that division is a limited operation, that you can't divide anything by anything else. And then you're learning about fractions and decimal numbers, and then you are told, yeah, actually we can complete this division with these special new values, special new numbers, decimal numbers. And that also is sort of acceptable, but what would be really not acceptable is if you were told in school, oh, 5 divided by 3 exists, it's 7. Because we already know what 7 is and we have intuitions about 7. So in the same way, being told the sum of all the positive integers is not a special new value infinity, but minus 1/12 is even more insulting to our intuition. So what's going on? Oh, right, of course. There are some other properties of infinity that we can add to this. Some other expressions that don't exist, but we can make the math consistent. So what's this third level that I'm talking about? It is to say, well, if there's no way of computing 1 plus 2 plus 3 and so on, yet we are not really forced to assign it anything special. We can actually have the freedom to assign it anything we want. And that is this new path that is being taken. And of course, we want this value that we can assign to it correspond to certain intuitions that we have about infinite sums. One of the intuitions I already listed before, an intuition about infinity, but there are some other things that we sort of think should be possible in computing infinite series. So for example, if I shift the whole series to the right with a leading 0, that shouldn't affect the result, right? A1 plus A2 plus A3 and so on is the same as 0 plus that sum. Or I could even imagine myself putting in an infinite number of zeros at every other step. So A1 plus 0 plus A2 plus 0 plus A3 plus 0 is the same as just adding A1, A2 and so on. And that's another step that Tony does in his proof. We can add infinite sums pairwise. So adding these two infinite sums amounts to adding the corresponding terms sort of vertically. There's a vertical notation for that in the proof, but that is what's basically going on. And the distributive property. So multiplying the whole infinite series by constant c is the same as multiplying each individual factor by c. So I think nobody would really, in any seriousness, doubt these properties. And then there are these two. So one property is 1 minus 1 plus 1 minus 1 and so on equals 1/2. So there's the first choice of assigning an actual value to an infinite series instead of just saying it doesn't exist. And the last intuition is that the sum of positive numbers A1, A2 and so on is larger than any individual term. And so what Tony does in his proof, he uses these properties to manipulate numbers and arrive at this weird result of negative 1/12. But actually he only uses the first 5. As it turns out, the first 4 are perfectly acceptable and give no problem. But the last 2 are actually incompatible. And we sort of are forced to make a choice which one we like to retain and which one we want to discard, because keeping both gives impossible results. So if we choose to accept the first property, or property number 5, but we sort of give up the last one, then we get this result negative 1/12. But if we reject the first property because we prefer to retain the second one, then the only sensible result that we can assign to this infinite value is, to this infinite sum, is infinity as we know it. That really is the crux in this whole computation. We have two quite good intuitions about infinite sums, and we're sort of forced to choose which one to retain. And I would argue that the property number 5 is less intuitive than property number 6. Anyway, this is why my 2 cents about this, that the intuitions that we have might be incompatible among each other. And so we are forced to pick and choose, and we get different kinds of mathematics depending on which intuitions we keep and which ones we discard. I want to post 2 other videos about this infinite series. One is more computational and the other is more visual, so keep an eye out for those.